All right, this is for the cumulative section for the study guide on chapter 4. But before we jump into it, especially that first problem dealing with trig, we need a little background knowledge. We need to remember a few things. And if this is totally new to you, then pay really close attention. So we've got right triangles. Okay? The trigonometry only works with right triangles. So let's say that this is angle A and this is angle B. Okay? The longest side, remember, is always the hypotenuse. All right, this is a leg and this is a leg. Now, when we're using trigonometry, we use the saying Sakatoa. Now, what in the world does that mean? Well, the S stands for sine. Now, it's going to be a ratio. Okay, the ratio is the opposite side over the hypotenuse. Okay, now that's not going to make any sense yet until I start using the numbers here, or the letters. Okay, the C stands for cosine, and that's adjacent over the hypotenuse. Now remember, adjacent means next to. Okay, and then the T stands for tangent, which is the opposite over the adjacent. All right, so here we go. So for example, let's say, all right, I want to do, how do I want to do this? All right, so let's say I'm going to be weird here and I'm going to use some symbols. All right, so let's say on this side we have a square and on this side we have a circle. All right, and I want sine of A. Well, opposite of A is what's across from it. So that would be whatever that box is over adjacent, which is next to, okay, or I'm sorry, the hypotenuse. I'm being silly. So over the hypotenuse, whatever that might be. So sine is the opposite side of this angle, which is the box, whatever that might be. It's going to be a number over the hypotenuse, whatever that number is. Okay, we don't have numbers right now. The cosine of that angle, in this case, the cosine, that would be, that is adjacent, okay, again, adjacent, whatever that is over the hypotenuse. Okay, again, it's going to be numbers, and we'll see what the one example that, or the practice problem that we have. And then the tangent of that angle is going to be the opposite, which again in this case is that whatever that box is, and then the adjacent is whatever that circle would be. All right, and then we could do the same thing with angle B. The opposite is across, adjacent is the next to. Okay, what else do we need to know? Well, when you're doing this on the calculator, you have to be in the right mode. Okay, so let's go to our calculator. All right, so the mode button is right here next to the second button. Okay, mode. Okay, see the red? That's your mode button. Now, to do trigonometry, you have to be on the third line and you have to be in degree mode. So hit enter. If you're not in degree mode, this is not going to work. Okay, so make sure you are in degree mode. If you're not, you'll never get the right answer. So those are some background things that you need to remember before you do the first one. All right, so here we go. So in this problem, we want to solve, oh, it says set up, but do not solve. Okay, well, I guess we're not going to need to worry about the calculator then. So all we're going to do is set this one up. So here's our angle, and this x is on the opposite side of that angle. This is the hypotenuse, and this 5 is adjacent to that angle. Well, what uses opposite and adjacent? That would be tangent. So we say tangent of 55 degrees equals the opposite, which is x, over the 5. Okay, we're not solving it. Okay, I think that's going to be on the next test. So that's it. We're just setting it up, but do not solve. All right, now number 30, we need to remember some information here before we can solve it. Okay, first of all, you need to remember the Pythagorean, well, part of the Pythagorean theorem. Well, no, the whole thing. So you know that a squared plus b squared should equal c squared. If that is true, that is a right triangle. Now, sometimes that's not always true. For example, if a squared plus b squared is greater than c squared, what type of triangle is that going to be? In this case, it's going to be an acute triangle. That would mean all angles are less than 90 degrees. Okay, all angles are less than 90. The third scenario is if a squared plus b squared is less than c squared, that would be an obtuse triangle. Now that means one of the angles would be greater than 90. All right. So we're going to check this one out. So we're going to plug the numbers in. So we're going to go 7 squared plus 8 squared. Whoops, that's not a square. There we go. And we want to know, what is it compared to 9 squared? Well, 7 squared is 49, plus 8 squared is 64, and that's 81. So we find out that this is 113, and this is 81. Well, the a squared plus b squared, that is greater than 81, therefore it is acute. All right, you're going to need to memorize that stuff, so it's not that hard. Little memorization doesn't hurt. All right, this next one, another review problem where we're going to need to use that point slope formula. Remember, y minus y1 equals the slope times x minus x1. So first we're going to have to find the slope. All right, so the slope is going to be 3 minus 1 over 4 minus 3, which is 2 over 1, or 2. All right, now I'm going to plug other numbers in. So y minus, okay, y1, I'm going to put 1 equals 2 times x minus 3. So that would be y minus 1 equals distribute 2x minus 3. I'm going to add 1 to both sides. So 2x minus 2. Oh, wait, I'm silly. Hold on here. I knew something was wrong. 2 times minus 3 is minus 6. Okay, so add 1. So y equals 2x minus 5. Okay, be careful. Okay, don't make a silly mistake like I just did. 2 times the minus 3 is the minus 6. Okay, next. Given the two lines are parallel, upon using elimination or substitution to solve the system of equations of the two lines, the type of solution that would be found is, okay, well, they're parallel. Parallel lines have no solution because they're never going to run into each other. If they cross each other, then that would be one unique solution. Okay? And if it's neither the one of those, then it would be infinite. All right, last one. Here we go. Solve the following using any method. Well, if I get to choose any method, then I'm going to go ahead and I'll show both, but I'm going to start with substitution. So that means here I would get y by itself, so that y would equal negative 8x plus 27. Okay, I'll show both, so you can decide which one you would prefer. Now I'm going to plug that back into the other equation. So I've got 2x minus 3 times negative 8x plus 27 equals 23. All right, solve for x. 2x plus 24x minus 81 equals 23. Combine like terms, 26x minus 81 equals 23. Add 81 to both sides, so 26x equals, let's see, that's 104. Divide by 26, x is 4. All right, now I'm not done because I only have half the answer, so I only have the x value. So now I want to know what the y value is. So I'm going to plug that 4 back into that one. So y equals negative 8 times 4 plus 27. That would be negative 32 plus 27, so that looks like negative 5. All right, if you prefer to use elimination, I would, okay, I'm going to eliminate. Now, again, there's more than one way you can do this. I'm going to get rid of the y. So to get rid of the y, I need this to turn into a 3y. That means I got to multiply everything by 3. So the top equation did not change. Now I'm going to multiply the bottom equation by 3. So that would be 24x, then plus 3y, and then 3 times 27, that's 81. So now the y's eliminate. All right, combining like terms, I end up with 26x, well, that looks familiar, equals 104. Divide by 26, and I find out that x equals 4. Okay, it should end up being the same answer because we're just solving it another way. All right, now I'm going to plug that in. I'm going to take that and I'm going to plug it into this x. So 2 times 4 minus 3y equals 23. 8 minus 3y equals 23. Take away 8 from 23. And I believe we're going to get 15. Divide by negative 3, and we end up with, oh, look, negative 5. All right. That's it for this study guide. Rewatch anything you need to. Hopefully you get an A. Good luck.